Chapter 1, Function Fundamentals. Ruben learned in art class that a mosaic is made up by arranging small pieces of colored material, such as glass or tile, to create a design. Ruben created a mosaic using tiles, then decided on growing pattern, and created a second and a third mosaic. Ruben continued his pattern by building additional mosaics. He counted the number of tiles in each mosaic and then represented the data in multiple ways. He thinks he sees a relationship between the mosaic number and the total number of tiles in the mosaic. Number 1. Represent Ruben's data from the mosaic problem in at least 3 different ways, including a general function rule to determine the number of tiles in any mosaic. For number 1, we have a verbal description. One way to look at the mosaic is to see the 2 tiles in the center of the mosaic, and this would be the center, these 2. For each new mosaic, add 3 outside tiles. So, for mosaic 1, we had the 1, 2, 3 tiles added to the center. For mosaic 2, we had the 1, 2, 3, 4, 5, 6 tiles added to the center, and the pattern continues for mosaic 3. We had a graphical representation and then a tabular. In the table, we use a 3-column process chart, and we determine that the function is 2 plus 3n. So our rule for the table is tiles equals 2, being the center 2 tiles in the mosaic, plus 3n, where n is the number of the mosaic. For number 2, write a description of how your rule is related to the mosaic picture. Include a description of what is constant and what is changing as tiles are added. For number 2, the function rule is based on the picture of 2 tiles in the center and 3 tiles added for each new mosaic number. As tiles are added, the 2 tiles in the middle are constant, and the number of tiles we add each time stays the same. What changes is the mosaic number. The total number of tiles that is included in our mosaic is dependent on the mosaic number. For number 3, how many tiles would be in the 10th mosaic? Use 2 different representations to show how you determine your answer. We have a graph and we have a table. So you can see how many tiles are needed, which would be 32 tiles to go into the 10th mosaic. Substituting 10 in for n, which is the number of mosaics, we determine 3 times 10 is 30, plus the 2 center tiles gives us 32. For number 4, how would there be a mosaic, or would there be a mosaic in Ruben's set that uses exactly 57 tiles? Explain your reasoning using at least one representation. Here we're looking at a table, or you can figure it out algebraically. We have 57 for the total number of tiles, and set that equal to our function 2 plus 3n, where we're going to solve for n. Our first step is we take the 2 and we subtract it from both sides, which gives us 55 equals 3n. The next step is to divide both sides by 3, and we end up with 18 1/3. Since we have to have whole numbers for mosaic numbers, we cannot have a mosaic number that has 57 tiles. For number 5, in Rubens' mosaic, there are 2 tiles in the center. How would the function rule change if the center of the mosaic contained 4 tiles instead? Explain your reasoning using 2 different representations. First, verbally, if the center of the mosaic contained 4 tiles, the data in the table would change. Each point in the graph would be translated up by 2 units. Another way you could explain it is that you have the function rule 2 plus 3n equals t, the number of tiles. If we change the 2 center tiles to 4, it is going to change our expression also to 4 plus 3n equals t.